podcasting club area or wherever it needs to be. All right, so talking about dimensions. Everybody's going to need highlighters, so if you haven't grabbed any, I now have cups full of every color. So you can take the entire cup and then just bring the whole thing back, and you can like rotate colors around your group because we don't need to all be highlighting the same color at the same time. What we do want to highlight, and I'm going to start with kind of my basic color, is if we measure things just by length. I live 2 miles from school. That is one dimension. That will be measured centimeters, feet, kilometers, miles, parsecs, fathoms, whatever one-dimensional length measurement you choose to use. I'm pretty sure parsecs are space measurement, like light years. You can probably guess what we're going to do with our 2 dimensions. We're going to highlight the same sort of stuff. Different color, right? Switch colors. Area measures in 2 dimensions, and that's why we use centimeters squared, is that's the result of multiplying centimeters by centimeters, which gets us centimeters squared or feet squared or meters squared. When you multiply centimeters by centimeters, we end up with centimeters squared. And then, like the sphere that came along and blew the little square's mind, 3 dimensions adds in thickness. Right? So, now Daniel actually in the other class was making some brilliant observations about like, okay, so especially in that video, they talk about like, okay, 2 dimensions is like a piece of paper. But why do you think we use the word like a piece of paper and can't just say a piece of paper is 2 dimensions? Vincent?
Because it still has like height, even though it's like super tiny.
Yeah, guys, there's this device called a micrometer, a micrometer, so like a meter stick, that like pinches down on things and can tell you very precise measurements. And somebody might say, well, a paper has no thickness. Well, that's wrong, because if I wad it up, it has volume. Right? If I put this into something, it will displace. Have you guys done displacement this year in science, where you put something into water and measure the change? Okay, so displacement is when you like put something into something else and stuff changes. So paper, even though we talk about it only having length and width, has a thickness. It's just very hard to measure. So pretty much everything in our world has 3 dimensions. It's all, what do we care about? If I'm going to paint this wall because I'm tired of this green, what do I care about? 1 dimension, 2 dimensions, or 3 dimensions? 2. The wall, I want the area of the wall so I can paint it. Just like right here, like I'm going to paint the object. But if I'm going to go to the store and buy the paint that I need, I'm going to buy a bucket of paint. What do I now care about? Volume, right? The coffee I drink every morning is volume. But if I spill it on the ground and it all spreads out, now we might be looking at what area did I mess up by spilling my coffee, right? So area versus volume. So, now I'm a tiny bit lost because flat land always gets me confused. So if you can imagine, and actually this, I need to scooch these down a tiny bit. If I did... So I've got a length of 1. Let's call this a length of 1. And since we're going to talk volume, I should probably just draw this. It's going to be harder for me to click things. And this might be just as easy to visualize. And now the cat's out of the bag, because you guys showed up right after the last class. 1 centimeter cubed. Because Mr. Tewart, the teacher here before me, was awesome. So here's literally 1 centimeter cubed. Oh, this is the thing I wanted to tell you guys. It's on my other notes, but I forgot to write it down here. So guys, anyone ever watch like Grey's Anatomy or ER or any of those medical shows like with your parents? Yeah, and you probably will a bit more as you get older. a lot of times in these shows, they're like, we need to get 50 cc's stat, or like 100 cc's. CC stands for, anyone have a guess? Cubic centimeters. CC stands for cubic centimeters. So this little bitty baby cube is literally a cubic centimeter. Scrap wood, essentially, but it's a perfect cube. 1 centimeter by 1 centimeter by... Now, here's the crazy thing. I was way too old when I learned this, so this is why I teach you guys some extra stuff. 1 centimeter cubed is also equal to 1 milliliter. That's where milliliters come from. A milliliter is a centimeter cubed. That's it. Like, so when we measure things in milliliters, it's really how many of these baby cubic centimeters could fit into it. So if I line up 10 of these, 10 cubes, what would be my volume? If I just line, it might be easier to see if I pull this out. If I line up 10 of these, what's my volume? If each of these cubes is you can only see the cuts on the one side. If each of these cubes is 1 cubic centimeter, and I line up 10 of them, what's my volume now? 10, right? 10 centimeters cubed. If I get another stack, 20. So what if I do 10 of these? I now have 100 centimeters. Now wait. So you said this is 100 cubic centimeters because it has thickness. But what would this area, if I'm going to paint this, what would this area be? 100 centimeters squared. So guys, this is a really weird thing. 100 centimeters squared and 100 centimeter cubed. 100 does not equal 100. Yeah, I always wait for at least one what? 100 does not equal 100. 100 centimeters squared is the space I would paint. 100 centimeters cubed is if I put this into something, how much volume does it have? Like water, right? Like our volume of water. So, don't get water on people. We're like 70% water. If you're afraid of water, we got to address that. So then, if we're talking volume, and I stack this 10 layers high, what would the so this, we said the volume is 100 of this, but 100 centimeters cubed because it has thickness. So imagine like, what just spooked Antonella, I fill this with water, right? But I stack it 10 tall. What's the volume of this?
100 centimeters cubed.
But didn't I do times 10? Didn't I multiply again? So if I multiply this by 10, now instead of 1 tall, now I'd be 10. What's 10 times 10 times 10? 1,000. So guys, if the last class decided they wanted to pass this around, so you got to pass it around. You can look at it. You can see every face of it. Every face has 100 little squares that we can see. Every face looks like this. But if I make it 3-dimensional and I fill the whole thing up, then it becomes 1,000 once I fill the whole thing up. And then it would be milliliters. Well, yeah. Well, milliliters doesn't need the cube, actually, because milliliters is already a cubic measurement, like gallons or cups or ounces. So, yeah, that's where it gets confusing. But if I had 10 of these, 1, 2, 3, 4, 5, 6, 7, 8, 9. If I have 10 of these, right, that I all stack up together, this turns into 1,000 cubic centimeters. Because each layer has 100. Questions? All right, so my notes in your notes about volume are way better because I didn't give you any surface area notes, actually. So while you're passing that around, make sure we're still highlighting. Let's move on down to here. Sorry it cut through. This made me sad that it cut through the V. I hope you can guess that that is volume. You could write a little V off to the side of it, too. Now, this is where you guys get to meet DJ Hudcap's sidekick. Big B. Well, some of you have heard that like another name that sometimes people call me is Lil Huddy. So we got Lil Huddy and then we got Big B. Okay, so Big B is actually, and I'm going to use the same color I used for area. Sorry, those little wood pieces. I'm going to use this same blue color. Big B is the area of the base. So please highlight that. And then actually, I'm going to label Big B over in my shape. A Big B. It's never happened. I mean, I don't know if you were expecting it to get a rise out of me, but that's been around since before you guys. One of you probably heard it from one of the 8th graders who heard it from like years before. So, DJ Hudcap, I think they didn't quite believe me that that name has followed me here. Like, I didn't make that name. It came from a radio station I was part of. Because, yeah, during college I was a radio DJ. So, yeah, I never stopped talking. Even if no one's listening. Everyone turns their radios off. I'm still talking. But yeah, so DJ Hudcap came to Phoenix, but they're like, no, we should call you Lil Huddy. I'm like, I don't care, whatever. Like, but I don't rap, right? I feel like Lil Huddy's kind of like a rapper name. So maybe, and actually Mrs. Hunter was giving, well, you guys don't really know Mrs. Hunter, but she was giving me a hard time that why don't I make any of those videos that I show you guys, like those YouTube videos? I'm like, I just don't have time. Maybe DJ Hudcap and Lil Huddy need to get together and make a math video. But Mr. Hudson has too many papers to grade. All right, so Big B, guys, this is the most confused part of this. So give me your attention. Big B is the area of the base that does not mean bottom. Okay, so base, like we live in a 3D world, and the bottom of an object can easily become not the bottom. It could become the top. The side, the back, the left, the front. We can rotate things. So Big B, why we talk about that is the base is the shape that is on both ends, and it's connected by rectangles. When we talk about a prism, and some of you might be thinking, well, this isn't connected by rectangles. This is... Wait. Because I love teaching math. When you take a cylinder, and how do you think I would do this if I didn't actually enjoy my job? I've been doing it for 10 years. I could have left. Cylinder, right? I can put it back inside the cylinder if you really want me to. If we take off the top base, and which don't have to be the top and bottom, I can lay it whatever way I want. But if I cut it down the side, so imagine like a pop can, and I unroll that, it's a bunch of rectangles. And really, it's one big rectangle. Who's ever like cut apart a pop can, even though you know it's going to be sharp and you probably cut your finger in the process? And, yeah, right? We all get bored. So if you cut apart a cylinder, it's really a rectangle. So again, the bases are connected by rectangles. So if we have something like this, what is the base of this object? A triangle, because there's a triangle on both ends, and it is connected by rectangles. So if I sit this like this, the base is the bottom. Right? If I sit that like that, the base is the bottom. But if I sit that like that, the base is still the triangle. It doesn't matter that it's not the bottom. Okay? Base does not mean bottom. You might want to make a little note of that. Height also doesn't mean height. Yeah, sorry. Height, I didn't do this. I just have to teach it. If I was in charge of vocab, we would probably just make up some more words. The height is the distance between the two bases. So however far it is between the bases, that is your quote-unquote height. Which sometimes is actually the height, and other times is not how tall it is. Right? It doesn't have to be how tall it is. It is the distance between the bases. So the height is how far from base to base. Now, if I were to encourage you to do something that will help you, instead of using the little h, I would use big B and big H. But big H is still just the distance between the bases. So don't confuse yourself. H is just going to be like 4 in this case. You'll see on the next page why using little h might be confusing. I will show you on the next page. Now hold it, don't flip yet. You got to solve this one. So, to find big B in the prism here at the right, how do I find the area of this rectangle that is conveniently at the bottom? Yeah, 3 times 2 or 2 times 3. I'd highlight this because, you know, Hudson did the work for you. So big B is 6 inches squared. That's our big B. Hey, big B. Then we multiply that by the distance between those big B's. And that's 4. So we multiply by 4. Times the height, which is really the distance between. And the volume will always have a label of units cubed. So since our units here is inches, because guys, it's how many of the little bitty cubes can we fit? It is literally, guys, I don't use that word loosely. Some people say literally and they don't mean, it is literally how many cubes fit inside. And if it's hard for you to think about, break apart the layers, right? How many cubes fit inside? Well, every layer has 100. I have 10 layers. I think I left a couple on the table, but how many cubes are in it? Questions? Square? You calling me a square? So then, math doesn't like for you to be like, okay, I get this now. As soon as you feel good, math is like, haha. Now, here's the lucky thing. Since we're only in 7th grade, you're not going to be asked to find this volume, or sorry, this area. Because to find this area of like a hexagon or something, what we actually would do, and you might not be able to see it very well, is break it up into triangles. Every shape can be made of triangles. You're not going to be asked to do that right now. They're going to tell you, hey, the area of this base. They will tell you big B is, and then we need to multiply by height to find the volume. Okay, so we're going to practice a few of these, but when the base is not a rectangle, flip your page. Now I'm going to get my color one back because it's easier to see. All right, check it. So look at this for a moment. Look at this for a moment. Here's why I said little h might be confusing. In this case, because our base is a triangle, and you might want to label these things, we have little b. Little b. Little b. Little b is the base of the triangle. Little h is the height of the triangle. Big H is that height of the prism, or the distance between them. So guys, that picture is this. It's this triangular prism. We need to figure out the area of this end and then multiply by the distance between them. So how do we find the area of a triangle? It's done for you. 1/2 times the little b times the little h. That's our triangle area. So you might on your paper, like, put this in parentheses, for this is all big B. They are trying to find the big B. And I don't love that they jump over the step. So I'm going to write it in. 6 times 4 is 24, but then half of that is 12. So the big B is 12 times the distance between the bases. The distance from base to base was 10. So I would show the work of big B became 12. Big B became 12. And then we multiply by that 10. Vincent.
How many triangles are in a circle?
I mean, we saw like infinitely many if we keep slicing them, but triangle, you kind of have to use a tidbit loosely since we'll have a curve on the edge of it. Or there's still infinitely many depending on how small you're talking, but then we'll end up with these conic sections that are a little bit complicated. It'll be like flat with a tiny bit of curve if we slice the circle into like perfect triangles. That's a deep question that we don't really have time for right now. We can probably circle back to that at the closer to the end of school. Over here for cylinder. In a cylinder, what shape is your big B? What shape is your big B? A circle. It's the base. It's on both ends. I know this because I can look through it and talk through it. It's the shape on both ends. Cylinder. Circle, circle. So, to find the area of the circle, or our big B here, big B, guys, you can make a little note off to the side. Big B is pi times radius squared. So big B is pi times 3 squared, which is really 3.14 times 9. That becomes like 28-ish, I think. 28.26. That gets multiplied by 8. And that's how we get about 226 millimeters cubed. Because how many little cubes would fit inside? So let's practice this with the examples down here at the bottom. And why are there ducks? Because I stole this picture from the internet and there were ducks on it, so I left them. And then I drew a top hat on my mama duck. Except not on this set of notes. So remember, volume is big B times H. Take a moment to practice this. And remember, H is not really the height, especially in this situation. I was going to send them in just a minute, if that's cool. because I just needed to get some teaching done, and then we were going to practice stuff. You hear me teaching? You believe me?
I hear what you're saying.
You want me to announce this like at the end of class, or? Okay. I called one of our incoming students a nerd on the Zoom call, and he got all offended. I was like, bro, you gotta realize nerd is like a compliment around these parts. Like when somebody does something really cool, we're like nerd, but it's like a compliment. So, what nerd would like to help me solve this? Do I need to figure out the area of the triangle? They did it for us! This is big B. This is big B. They gave us big B here. They gave us big B here. Because they tell us the area. But notice, it's not the bottom. It's not the bottom. Come on, focus. Come back. There we go. All right. You know them, you love them, you missed them while they were gone. Random cards. Layla Davis, what is the height of the triangular prism here? Can you make a guess, because there's only one other number on our image? 8! You are absolutely right. Because the length, the height, guys, you could highlight it right here. Right, for us down here is the length from front to back. Because how we've laid down the prisms. So this is our quote-unquote height in this situation. Now, if I pick that thing up and set it down the correct way, we can put the triangle on the bottom. Well, okay, yes, thank you, Ender. There is no up in space. There is no, like, north and south when you're floating around the space. So, to find volume, we will do that 9 times 8, because volume is big B times H. They gave us big B was 9 times our height of 8. What's 9 times 8? Thank you. Much appreciated, Eve. Centimeters. If it's volume, cubed centimeters. How many baby cubes fit inside? What? We only have 6 minutes left? How did this class go by so fast? Yet. Words hurt. All right, again, volume is big B times H. If we know big B, we can just jump right to that multiplication. They give us big B because we don't really know how to solve a pentagon. So our big B here is 15. What's our height here? 9. And we get a volume of 135 centimeters cubed because it's volume. Try the last one if you haven't. Careful. There's not just one other number there. There are 2 other numbers. We have to figure out which one of those is the height. Anyone want to make a guess for us? Which one of those numbers, either the 6 or the 10, is the height? Eve? Yeah, because the 6 is how far from front to back. This is 6, making 6 our height. Very good. 80 times 6. What's 8 times 6? 448, I think. So 480 centimeters cubed. Bless you. All right, so now I thought we might have a little bit more time left. Pull out your Sharks Eat Clowns worksheet, and let's do a few of these so you get some of your problems done. I'm going to grab another copy so mine's blank. Why don't sharks eat clowns?
Because they're not tasty.
Did I already tell my cows and sheep jokes in here?
I don't think so.
Why is the sheep excited about spring break? Because it's going to get the sheep in. Every day. Why is the cow excited about spring break? Because he's going to the movies.
Oh, you told us that one. You can go at...
No.
That's just no. No.
Why is the pig excited about spring break? Because it's spring break. Jeez, duh. Layla? Look, it's just my thing. It is like, yeah, it's what makes me me. I'm gonna have to buy a joke one of these days. Next time I go down to half price books, I might look. I'll probably get down there over break. Man, I was able to give the other class a few minutes to do this on their own. I want to jump right to let's jump right to 3. Well, first off, in 2 and 7, they give you Big B. So pay attention. We don't have to solve Big B in 2 and 7. They give it to us. All of these other ones, we have to solve for the base area. So in 3, Aiden, what is the base shape in 3? The triangle, because it's on both ends. So, how are we going to find Big B? Well, it's going to be little b times little h divided by 2. Remember, those values have to be perpendicular. So the 4 is right here. The 12 is across back here. Those are the base and height of our triangle. So 12 times 4 divided by 2. So that gets us 24. So Big B is 24 inches squared. So that's Big B. What would I multiply that 24 by? The 15, because that's the distance between the bases. And here, it's actually the height, right? It's stood up correctly. It's actually the height there. Okay, correct. Nicely. Not nicely? Can I get away with saying nicely? Sure. Okay, I'm glad I have your permission. This is another cross it out. So I grab my calculator, do the Big B of 24 times 15, 360. Find that, cross it out. Cross out the letters that go with it. Where's the, PR. So down at the bottom, you find 360, cross it out. Now guys, put a little 3 in this box so you can remember that that was number 3. (24 by 15, yep. Because 15 was the distance between the bases, 24 was our Big B. Questions? Let's jump to 8. We'll do that real quick before you guys get out of here. Guys, please write this work out, because a lot of us are still we're still getting comfortable with trapezoids. Our Big B here is the trapezoid. This shape on the end, because it's on both ends. So to find our Big B, we take the sides of the trapezoid that are parallel, add those up, divide by 2, and then multiply by the height. So I'm going to write this out because I know I just said a lot. So 4.7 plus 2.1, I divide that by 2 to average out these two bases, and that will get multiplied by the height of the trapezoid, which is 2.5. So remember, we're recording, so if you need to go back and see a reminder of this. So 4.7 times 2.1, divide that by 2, then multiply that by 2.5. So Big B, 12.33, so like 12.3-ish. But I can leave that in my calculator for a moment. What would I multiply this Big B by? How far is it to the other base? 5.8. So that times 5.8, we get 71.5, 71.6, something really close to that. I'm I'm wondering if we needed to round more. I'm wondering if this one's supposed to be that 72.4. Because if we had rounded... I'll make sure I did all my calculations correct. So we're out of time, so we can come back to this one next week. I'm wondering if it has to do with a rounding thing. Yeah, week after.
They were doing that to me yesterday.
Yeah. You guys know what I mean, the next week.
Next week.
Alright, remember, if you got these homeworks, turn them in. Yo. Oh, yeah, because this is meters cubed. So maybe I goofed something up. Maybe I goofed something up. 4.7. Oh, I found it! I multiplied instead of added. I totally messed this up. I made a goof. This is wrong. So I should be doing, I'm still recording, so that's the good thing. 4.7 plus 2.1. That divided by 2, then times 2.5, then times 5.8, 49.3. It's BO. We get to cross out BO. Yes, I know. Your schedule got goofed up. Give me just a second.
Have a nice day.
So, the video is not up